Hi, welcome to Cloud Cover. My name is Steve Marks.
And I'm Wade Wegner.
Every week we say we have a special, amazing week. Yeah. And I would like to just say, we just have a week.
Yeah.
It's not special. It's not amazing.
Yeah.
It's just a week.
Yeah.
All right? Some weeks can be like that. But it's still going to be good. You're still going to like it. We're gonna talk about scalable counters in Windows Azure.
Yep.
And before that, of course, we're going to cover the news, and then we'll wrap up with our tip, as usual. Should we start the news?
Let's go to the news.
All right. First news. Who cares?
Introducing the Windows Azure App Fabric caching service.
Yeah.
It does kind of make it sound like we're launching or something, doesn't it?
It does. When you sent me the link, I was like, what? What happened? Did something...
So, to be clear, so the news here is not that we're releasing the caching service right now or anything like that, but we're introducing it. So it's still in CTP form. Karan Deep and I, so Karan Deep is the group program manager within the Windows Azure at Fabric team. We wrote an article on the caching service, really to just introduce people to it. And so what is it, when to use it, and we talk through patterns for using it, some kind of behind the scenes, how does it work, and then we get a little bit more pragmatic and show you how to set it up and start using it within your applications. So, and one thing I'll note too is next week at Mix, Karan and I have a session on building highly performant web applications with the caching service. So
right. So if you don't want to watch that, then you can just read this.
You can just read this, exactly. Or if you really don't want to read a very long article,
it is kind of long.
You can watch the. Are the mixed sessions going to be available?
Yeah,
okay.
I think they'll probably be all. They're usually available fast, like within 24 or 48 hours. Okay. Now I'm going to be held to that somehow, even though I have nothing to do with it.
So
that's cool.
Yeah.
Although I do have to say, this is like in a magazine, right?
Yeah, we
it's
actually wrote it a couple of months ago, which was challenging. You think about the services world and how quickly it moves.
That's like a risk.
Exactly.
You're taking this bet that a couple months later, the code you wrote would still work.
Well, much of what we wrote, actually, we wrote against internal environments so that we were up to date at least when it was released. So.
Cool. All right. Moving right along. Windows Azure Code Quick Start. So these are some new resources that are on MSDN, and they're sort of getting started ones, right? They're how to start doing some of these things.
Quick start,
but they're quite good. Like I don't know, which one should we? Let's
WCF service.
Click on the WCF one.
I like this one.
Pretty detailed, and so it's at the detail where if you've never done this before, you'll be able to follow all the instructions.
I mean, it's essentially a tutorial. It walks you through the steps, shows you the code, and actually provides some background as well in terms of what is it that's going on.
Yeah, it's not one of these, well, if you follow all the steps at the end, something will be running, but you don't really understand
why.
it.
Yep.
This one is actually, I'm quite impressed with all these quick starts, actually. They're pretty well written, and they're detailed, and they're right. Like, there aren't steps missing or whatever.
Yeah.
So
did you go through and check them all? Step by step?
I reviewed all of them. I did not go through and try them, but they looked good to me. So if you find things wrong with it, it's my fault that I let those things through.
So we've got 5 right now, right? So there's 5 quick starts?
Yeah, let me back up. Yep.
So
and there will presumably be more over time. And actually, one of these is kind of, this one, even if you are not new to Windows Azure, you probably have not written a console app that uses the Service Management API.
Yeah.
And so this one's kind of cool too. Just it goes from making a certificate and uploading it all the way through full sample code that calls the Service Management API, gets back XML, shows you, it lists your hosted services.
Is it just C# or is there a VB version of
I think this is only C# for now.
Okay.
I think.
Okay.
But you could basically just recompile it, and it just looks like VB. It's no different, really. Okay. Let's go on.
So this is
Japan.
This is a neat story. So given the earthquake and the tsunami and the disaster in Japan, some folks have come together to provide some relief in terms of helping provide some relief to websites that are under quite a bit of load. So some of the Windows Azure MVPs, some folks in Microsoft and others have created some websites that'll help share the load so that folks can still get access to different, go to places and still get information that they need. And so you can see here a number of mirrors have been set up to offload some of the load on the actual sites.
Yep.
So it's a neat use of Windows Azure in order to help provide some relief there.
Very cool. Yep. A very nice thing that people did. A lot of our MVPs and other MVPs kind of drove this stuff, which is really nice. Okay. eBay, iPad, and Windows Azure together at last.
Yes.
You know, everybody's always said that's a combination that made a lot of sense. And so finally, you know, we actually put them together. This is kind of cool. eBay's marketplace for iPads. So if you go to ipad.ebay.com, we rehearse saying that in stereo like that. If you go there, that's actually being backed by Windows Azure. It's eBay's Java infrastructure running Windows Azure.
That's interesting. I mean,
technologically
it's
interesting.
Java, right? It's not. They didn't stand up a set of .NET services. They're actually utilizing their Java services within Windows Azure.
And this was sort of, they wanted to test something kind of at scale with Windows Azure, and so this is what they're doing.
And what needs scale more than iPad on eBay?
eBay does. Did you see this number in here? $2,000 in sales every second.
That's a lot.
In the year 2009.
Yes, $60 billion.
That's pretty remarkable. So very cool. eBay, of course, is
to be
also.
clear, that's not for their iPad sales, I don't think.
No, that is just in 2009. iPad sales were $2,000 a second. eBay is also, of course, one of our partners for the Windows Azure appliance, and so they're also looking at putting the Windows Azure appliance in their data center and running some things in there. That's stuff that there's ongoing work on. That's about all we can say about it for now. But they are doing that. It's interesting. I wanted to call that out because they're a company that's actually looking at using both the appliance and the public cloud.
Yep.
That's their plan long term, is that they're gonna have both, and they're gonna have the public cloud for those kind of spiky or unpredictable loads, or basically to get the elasticity, and then the appliance because it's just an efficient way for them to run their data center and to use code that's the same across both. And whatever. So very cool. eBay's been a fantastic partner on this stuff, and they continue to be. So cool.
It's great.
All right. Google came out with this button. This +1 button. You run around the web and you go, yeah, I like that, and you hit this button.
Wait, you like that, or this is pretty cool? Because
you should check
say
this out.
it's not like, right? Because Facebook has the like.
It's not a like button.
It's this is pretty cool, or you should check it out. In fact, I thought +1 was more of a Microsoft thing. I'd never seen all the +1 references until I came to Microsoft. Because you'll be on these email threads, and you just wish they'll stop, but people keep replying all with +1.
Yep.
Right?
They just want to make sure
support.
that people know they also think it's pretty cool and that you should check it out. So anyway, I don't know. I don't know about you, but when I see something like this, I just don't really care that much.
And
then we see this.
Yep.
LinkedIn.
I think this is as of today, so this is hot off the presses.
This is like right now. They have this share. I guess is just the logo.
So it's a share button.
So you click this, and I let people know that.
Go back to your site. I don't know if it's to your LinkedIn profile or.
I don't know what it does, but Wade and I have the same reaction when we see these things, which is like, meh.
What's the point?
Yeah, I don't know. So what we really thought we need.
I mean, we feel a little apathetic when we see it.
Yes.
Like,
so we need. I want an apathy button. Let's just search on Bing for apathy button, because that would be great. And look, there is one.
There is one.
There's an apathy button. And I just don't care. I'm just going to click the button. I don't care. And let's see, the number went up 6 apparently.
Well, I think people are also clicking it. See?
Yeah, it's going up by 35. Itself. It looks like a lot of people
just don't care.
And so this is our demo for this week. Thank you. We should start by saying thank you to everyone who, since last night, so we recorded this on Wednesday morning, Tuesday night at like 11
o'clock we released
this. We tweeted this thing, and we got 10,000 clicks on it overnight.
Yep. There's a lot of apathetic people out there.
Thank you for being so apathetic that you care enough to click on the button. It's a bit of a contradiction.
Yeah.
But what we wanted to talk about on the show this week is the technology behind something like this, which is actually, it's harder than you think to run one of these things. Because you basically have this massive concurrency problem. You can scale this out to a bunch of servers, but then you have this question: how do you keep one count? How do you keep it accurate and up to date
across all of these instances?
But spread out across all this?
I mean, on the one hand, you may just not care, right? Yeah. Which wouldn't be appropriate here. It's like,
you might just not care.
Maybe I'll lose a few apathetic clicks.
Right, because there are a number of strategies to this, and they have varying degrees of sort of accuracy or consistency.
Yep.
And so there are a few different things you can do. And right, one of them is certainly every time somebody increments a number, they put in their best guess for what the current amount is. That's actually a reasonable strategy if you don't care about counting every single click, but you just want to make sure you usually have the right number,
close,
or you're close, right? And so if there's some sort of concurrency problem, fine, we just lose some set of updates or something. And that's one strategy.
But there's a contradiction here because we're not so apathetic that we want to lose
Right.
anyone's click. We actually care about people's apathy here.
We care, and so we've thought this through and come up with a few patterns that some of our customers have used and have been used on other platforms to do this in a concurrency safe way to actually count all this stuff.
And to be clear, we'd been thinking about doing this for a while, but we just never got around to it.
Yeah, we just every time it came up, we were like, yeah, I guess we could, but eh.
So, well, why don't we first, before we drill into your code, why don't we actually walk through some of these patterns and talk about it a little bit.
Let's go to the whiteboard.
So how about you go ahead and describe the problem for us?
Alrighty, so here's the problem. So the basic problem is we've got a bunch of instances running in Windows Azure. We've got requests coming into all of them, potentially at the same time.
Yep.
And worse, we have potentially several requests coming into the same one at the same time. Okay, so we have sort of two levels of concurrency problems here. Because then what they're all trying to do is update something. Somewhere there's this count.
Yep.
And it's 5, and we want to increment it to 6, 7, 8. And they're all trying to hit this thing together.
Yep. And not only increment it, but then also get back what the current count is as well, right?
Yeah, so I mean, it's both problems, right? There's also sort of the how do we display back to the user kind of what the count is, and how do we know that count is accurate, or how accurate can that count be? Because really, once you have multiple things happening at the same time, there's no right answer anymore. It's sort of the it was Einstein's thought experiment about simultaneity, where he's on a train, he's looking at a mirror out the side, and lightning strikes two places at the same time. Anyway, short story is there's no such thing as simultaneity. It's all relative. And that's true in a distributed system. You really have this question of, well, something came in here, and before they both updated, which actually happened first, and what's the right number when you say it's actually an unclear thing. So you need to decide things about what's your tolerance for sort of how out of date the count could be, what happens. So let's do the naive thing, right? So the naive thing would be each of these instances is just updating like one row in a table somewhere. This could actually be SQL Azure, or let's just take the example of an entity in table storage.
Yep.
So there's one entity called count, has a number. They all try to update this. And the problem is that, well, what will happen, what will protect you from sort of concurrency errors is that table storage uses optimistic concurrency, which means when you go to update this from 5 to 6, there will be an error if it's no longer 5. So you're actually updating the version of this entity that you already saw, and that's protected by E tags and conditional headers in HTTP. And so you'll read this and see a 5, you'll add a number, then you'll get 6. You'll go to write it and write a 6. That works fine if only one person is doing this. If two of these guys are doing it at the same time, he'll read a 5. So he's going to read 5. He's going to read 5. I should have written these one lower than the other. He's going to try to write 6, and he'll succeed. He's going to try to write 6, and he will fail because of optimistic concurrency. Now, you could decide you don't want optimistic concurrency. I'm just going to overwrite whatever's there. And this is back to the, well, we don't really care if we lose some of these things, right? And so then what would happen is he'd read a 5, he'd read a 5, he'd write a 6, he'd write a 6. Everybody would succeed. The number would say 6, but of course it should be 7 because we meant to increment it twice. And so this is the, I don't really care. We'll just lose if two count updates come in at the same time. We'll lose one of them. It's sort of the last one wins kind of thing. This is a reasonable approach for a bunch of things, but you have to decide that you think that's okay for your application. We actually cared enough to want to know how many people didn't care and actually click this button. So we wanted an accurate count, which means we do want optimistic concurrency. It's going to protect us from some things. But if we just do this, when this fails, you'll just try again, right? We'll read the new value. It's a 6. We'll try to write a 7. In the meantime, somebody else updated it. once this starts to hit the scale that we saw of 10,000, it's now...
Well, now we're approaching 14,000.
By the time we're done explaining this, we'll probably be over 14,000. And by the time you get to actual significant scale, this ends up, everybody's just sort of deadlocked. I mean, there's one write is going through every once in a while, but everybody else is just in this loop retrying, and it doesn't work very well. So there are a couple solutions to this. Let's talk about one model where you have a single writer. And then we'll talk sort of about a special case of that. Right, so this idea is, well, the problem that we had was everybody's trying to write to the same thing at the same time. So let's stop doing that. And so there the idea is that you have one guy who's actually allowed to write to the table. So he's allowed to update that count, right? And everybody else has to somehow go through him. And you might say, well, okay, we've just traded one problem. They're still all trying to update him at the same time. How is this possibly going to work? Well, he might be able to handle the concurrent updates. And in fact, one common thing that you'll put here is you'll use, it really looks more like this, which is you will put a cache here, or any sort of storage that handles atomic increments. So one example of that is AppFabric caching service, which has an atomic increment operation, which means they can all say just add one. It's no longer I think it's 5, make it 6. It's add one to whatever the current value is.
+1.
Right. It's +1. And so then this guy just sort of pulls from the cache every once in a while, grabs whatever the current number is, and writes it out to this. So here in the cache, we sort of always have, we don't lose any of those updates, unless, of course, we lose the cache, because it is a cache, right? But the increments all happen with no concurrency issues. Here, we take from that cache and we sort of push into storage every once in a while. This could even be very free. This could be once a second. That'd still be fine. As long as you have one guy doing it, you're not going to run into these kind of concurrency issues. And this model works fine, because if you're doing this once a second and you do lose the cache, you'll have lost a second worth of updates, which is usually not that big of a deal. And so that's kind of your tolerance for inconsistent answers here, is you're willing to lose up to a second worth of stuff. And so that's how you set that timer. This would work fine. This isn't what we ended up doing for our apathy button. We did something a little bit different. Let me draw what that looks like. And it's back to, well, the problem was all these guys were writing to the same entity at the same time. So let's have them not do that anymore. And let's make a table where this guy writes to this entity. This guy, this is going to get complicated. This guy writes to this one.
There you go.
Yeah. If I'd done that from the start, this would have made more sense. Anyway, each one of them has their own row. So this guy has a count of 20, and this guy's count is 3 and 7 and 11, right? And so they all have their own count. They're the only ones writing to it, so there's never any sort of concurrency problem there, because this row can't have changed unless this is the guy who changed it. So you never have that kind of, I read the wrong number and wrote this. But now you have the problem of, how do you report back the right number?
Well, and real quick, so to be clear, so what we've got here is a table that's partitioned across the counts for each instance, right?
Right.
So,
and it doesn't have to be partitioned in the partition key sense. It just means they each have to have their own row, right?
Exactly.
So they're each writing their own thing, and that will avoid all these sort of concurrent updates to the same entity problems that we had. But now you need to know, well, what's the actual count, and that's the sum of these numbers, right? So to get the count, now you have to query the table, list all the rows, which is going to usually be the number of instances you have, and sum them. That turns out to be really fast and easy to do. And so, and you're, back to, well, how truthful is that answer? It's again, well, this guy might be about to update or something, and so it's not
as truthful as the timing of your polls for the get, right?
Exactly, and so so it's pretty good. The point is, that's a pretty accurate answer.
Yeah.
These numbers always go up, so you don't have there's a bunch of weirdness you don't have with the solution. This works great. I do want to talk about one more thing, and then we'll just skim through the code and see how this works.
Let's point out real quick, we are fast approaching 15,000.
Oh, yeah, geez.
So there's a lot of apathy going on right now.
That is. Let's see if we can finish before we hit the 15,000.
All right.
Okay.
It's like a timer.
Yeah. All right, let's go. So we do have one remaining problem that I want to point out, which is this problem of what about multiple updates going to
Yeah.
the same instance at the same time. Because now you have several threads here that are still trying to write to the same entity. That might be a problem. There are a couple solutions. One is you can have more counters than this. Like you can have whatever the max concurrency is you support in your web server or in your web app, you could have that many counters for each of the instances. And then you'd basically be back to this kind of thing. Another thing that you can do is do a similar sort of pattern within this, which is that each one of these threads, now I'm drawing so small no one can possibly see, is really updating a number that's gated by one thread, one master thread. That's what actually does the writes to the table. And so this is a little bit of concurrency awareness within the app and multi-thread awareness in the app that will reduce this down to one per instance. And then at the table, we have one per instance. And so now we've got a flow through this whole thing that will work. And that's what we actually implemented for the apathy button.
Great. Excellent. Oh, we barely
but
made it.
But we were about to switch.
We had wrapped. We had wrapped.
All right, let's go back to the cloud.
All right.
So we came up with a new measurement of time, a new unit for measuring time, which is clicks.
Well, it's meh.
It takes us about 400 mehs to move a camera so that we could switch back to this view, which was like less than a minute. So anyway, that's very cool. Let's actually check out the code and show how this stuff works. So we built this solution here that I'm not going to show all the cool stuff Wade did, which is the Ajax awesomeness of the UI. I'm sorry, Wade. We're not gonna. People are gonna have to download the code. We'll put this up. I guess I'll put a blog post out, and we've got the code out, and we'll give the code out. So you'll see a link at the bottom of this video to get the code. Then you can check out all the awesome UI-ness too. But let's focus on the counting part of this, which is so. Let's show the actual update. So this is sort of the loop that we're doing. That maybe I can make this even bigger. So this is the loop that is actually saying, well, every 5 seconds, check to see if the counter, if our local count has increased, and if so, go write it to table storage. Yep. So this is that one thread that's running constantly that's just checking, do we have any updates to send? If so, send them to our entity in table storage.
Yep.
And then we've got current count. Reformat a little bit so we can see, which is basically doing a query for everything in the counters table and then summing them.
Yep.
Notice, by the way, this is just as a small aside, notice the toList in here, and that's because if you just put .sum, it will try to turn that into a query against table storage. So the WCF Data Services client will say, oh, he's trying to do a sum. Let me put that as an operation that he's sending to table storage. And then table storage will say, well, we don't do sum. So stop asking us.
So you're just getting a list back from table storage and then summing it.
The toList basically says, well, bring it all down locally. So I'm bringing the list down locally, and then I'm summing it in memory. And of course, this list is how many? We've got 5 instances running.
Or 5? We have 5 now?
I think we're 5.
Excellent.
And so we've got 5 numbers.
Great use of all those instances.
Yeah, because we totally needed 5 instances for this. And that's about it. So, and then let's talk about the increment.
Okay.
Because now the increment is this thing that you've got to be thread safe about, right? Because remember back at this thread that we had going, we're just sort of checking this count all the time. Count is just a static int that we've got. And we want to make sure we don't lose updates. If you just do count plus equals 1, you've got the same kind of concurrency issue, except much shorter time period, where you've read the value, you've added 1, and then you try to store it again. You could lose counts if we're really serious about not losing anything.
Which we are.
Because we care.
Yep.
Or we don't. Then you want to do something like this. Interlocked increment is basically a thread-safe way of doing an atomic increment of an integer locally, right? So we're doing that to just update this count by 1. So every time the Ajax call comes from the client to increment the counter, we do this interlocked increment. The count goes up. Within the next 5 seconds, this thread will wake back up from its sleep. And we'll come here, check to see if anything's changed, and if so, it'll update that single entity and save it back to table storage. Yeah. So all the threads doing this interlocked increment, this one thread doing those updates. That's really about
kinda
it. I think, we should show one more thing here, which is the model for this entity. So this is the counter entity. It's probably the simplest table entity I've ever written. It's got one public property, and it's the count. The thing that I wanted to call out is this stuff, which basically says when we make a new counter, what we're using as the partition key is the deployment ID. I actually now regret doing this. So last night when I put this bit of code in there, my thinking was that we wanted to separate different deployment IDs from each other. So if you're testing something locally, it wasn't updating the count that was in the cloud. But that, of course, means if you update the code, you deploy something new to staging and then VIP swap it in, it's got a new deployment ID, which means you're now back to that partition is back to a 0 count, which isn't really what I wanted. So I ended up making the query all the partitions anyway. And then using this as a partition key is actually bad, because now my query is unnecessarily a scan of multiple partitions, which is slower. And so it would be better if I really made a single partition and then made the row key perhaps include the deployment ID. So that way, if you ever wanted to clear stuff from one deployment or something, you could do that. But
really, I mean, in the end, how much do you care?
Yeah. So anyway, so that's all. That's kind of how these different entities show up there, and they're unique by the combination of deployment ID and instance ID, which means you'll never have two of these running at the same time that have both the same deployment ID and the same role instance ID. Which means you'll never have two different instances trying to hit the same entity, and that's why it's important to use these. I don't quite like the decision I made about how to use them in the keys, but you do want to use both of these to be the unique key.
That's great.
And that's about it. What are we up to now? 18,000.
Oh my goodness. All right.
Wow.
Well,
so
thank you for
that time of the.
Well, actually, real quick.
No, he was going to say thank you. I want to stop. Thank me.
Actually, no, I'm beyond the thank you.
Please do.
No, I was going to say thanks for the background. Okay. I think we wanted to kind of share two things, right?
Yeah.
One is, we may or may not decide to keep the service running for a long time. I mean,
how much do we care?
How much do we care?
Yeah.
But we've also thought about extending it a little bit, right?
Yes.
So there's like buttons, there's +1 buttons, there's share buttons. Is that what the link is?
Share, yes.
And we may create an embeddable button at some point.
That way you could put it on your website and see how many people got there and then didn't care about the thing you found, which I think would be great.
I think it would be pretty cool.
I'd like to have one on my blog.
If we build it, it'll be on my blog.
Because I would like people to show up and then go, yeah, this didn't really matter to me, and just click the button and leave.
And what we thought is we could then track what site it came from, and then this site as well could just be like a global apathy landing page, right? If you're just feeling apathetic, click the button. But we could also show the top most apathetic sites.
Yeah.
Does that work?
Viewers of this site are the most apathetic.
That's probably the better way to phrase it. But let us know if you're interested in that.
Yes.
We may get around to doing it.
Yeah, or we might not. So it's about that time of the week when we do our tip of the week, which is usually something related to what we're doing. And we always ask Bob to put something in as a sort of intro.
And we can ask, but
Bob, I don't know, whatever. If you feel like
it,
put something in.
That'd be great.
So here's your tip of the week.
Will I be pretty? Will I be rich? Here's what she said to me. Que sera, sera. Whatever will be, will be. The future's not ours to see.
And we're back.
Yep.
I had a tip, but I
Yeah.
just don't care.
Don't care.
All right, we're not going to have a tip this week.
Anyway.
So we'll be at Mix next week.
Yeah.
And so if you want to watch us live, we will be on Channel 9 Live at some point. Do you remember when it is?
It's Tuesday, on half an hour after your session ends.
Oh, that's right. It's Tuesday afternoon.
So go look to find out what time Steve's session
I think it's 3:30.
And then,
because I think my session is 2 to 3. So I think at 3:30, 3:30 to 4, and 4 to 4:30,
yep.
which is sort of covering two different things.
Yep.
But we'll be there live on Channel 9. And of course, the deal with Channel 9 Live is we want you to tweet a bunch of questions you have about the stuff that we're going to be talking about, and then whatever that is. And then if we care, we might answer your questions, and we'll have some guests on who are going to be answering your questions and things like that. So be sure to check us out live next week from Vegas at Mix on Tuesday afternoon.
Yeah.
And that will be, so we won't have a recorded show next week. We'll just have that one, and then we'll have some sort of show the week after Mix happening. As always, tweet us at Cloud Cover Show, and be sure to go to www.apathybutton.com and show us how little you care.
Thanks.
Thanks.